Here's something that doesn't make sense. Matter is mostly empty space, like 99.999% empty. If you took all the actual stuff inside every atom in your body and compressed it together, you'd end up with a speck so small you couldn't see it with the most powerful microscope ever built. And yet, you can't walk through walls. You can't push your hand through a table. When you sit in a chair, you don't fall through it. Why not? If atoms are basically nothing, why does the world feel so solid? This is the contradiction that drove J. Robert Oppenheimer to dig deeper than anyone had gone before. And what he found down there in the guts of the atom is going to shake everything you think you know about reality. You're not ready for this, but I'm going to tell you anyway. Look, most people go through life thinking matter is solid. That's what it feels like, right? You knock on wood, it's hard. You touch metal, it's cold and firm. Everything around you seems substantial, real, there. But here's the thing that Oppenheimer understood better than almost anyone in history. None of that solidity is real. It's a lie your senses tell you because your brain can't handle the truth of what's actually going on at the subatomic level. And once you see what he saw, once you understand what's really happening inside every atom of your body, inside every atom of the air you're breathing, inside every atom of the screen you're watching this on, you're gonna feel different about existence itself. The world is gonna look stranger, more fragile, more miraculous, and honestly, a little more terrifying. And if this kind of stuff blows your mind, hit subscribe right now, because I'm just getting started, and what's coming next is going to completely rewire how you see everything around you. So, let's go back to that contradiction. You've got atoms that are almost entirely empty space. The nucleus at the center, where almost all the mass is concentrated, takes up about 1/10 trillionth of the atom's volume. Imagine a fly in the middle of a cathedral. That's roughly the scale we're talking about. The rest is just electrons existing in this weird probabilistic cloud around the nucleus. But even those electrons aren't really there in any solid sense. They're not little balls orbiting like planets. They're more like mathematical possibilities spread out in space. Ghosts, smears of probability. So if you zoom in on your own hand, past the skin cells, past the molecules, down into the atoms themselves, you'd find almost nothing there. Just emptiness with tiny concentrated points of something that barely qualifies as being there at all. And yet that hand feels solid to you. It can grip things, it can punch walls, it can hold the people you love. How does almost nothing feel like something? This is where Oppenheimer's genius came in. He understood that what we call solidity isn't about matter touching matter. It never was. What we experience as touch, as hardness, as the feeling of things existing, it's all about forces. Invisible forces. Electromagnetic repulsion between electron clouds that never actually make contact with each other. When you touch a table, your hand doesn't touch the table. The electrons in your skin get close to the electrons in the wood, and those electrons push back against each other with electromagnetic force. That's what you feel. Not contact. Force. Your entire experience of physical reality is an illusion created by invisible forces between clouds of probability. You've never touched anything in your entire life. Not really. And Oppenheimer saw this. He understood this at a mathematical level that let him see deeper into the nature of matter than almost anyone before him. But that was just the beginning. Because once he started pulling at this thread, once he started asking what else might be hidden in the atom's apparent emptiness, he found something that would haunt him for the rest of his life. Here's what they teach you in school. Matter is made of atoms. Atoms are made of protons, neutrons and electrons. Protons and neutrons are in the nucleus, electrons orbit around them. Nice and neat. You probably drew diagrams of this in 8th grade science class. Little circles with smaller circles going around them. The solar system model of the atom. And that makes sense, right? We like things we can picture. We like things that behave like familiar objects. So we imagine electrons as tiny balls whipping around a bigger ball in the middle, held in orbit by electromagnetic attraction, just like planets are held by gravity. Except, here's the problem. That model is completely wrong. Not a little wrong. Completely wrong. The electron doesn't orbit like a planet at all. It doesn't have a position until you measure it. Before measurement, the electron exists everywhere and nowhere simultaneously. It's a probability wave spread through space. Schrödinger's wave function describes not where the electron is, but where it might be when you look. And when you do look, when you make a measurement, the wave function collapses and the electron snaps into a definite position. But here's what's wild. Where it appears seems to be genuinely random. Not random like we just don't know enough to predict it. Random like the universe itself doesn't know until the moment of measurement. This is what quantum mechanics revealed in the 1920s and 1930s, and it disturbed physicists so much that Einstein famously refused to accept it. He said, God doesn't play dice with the universe, but the experiments kept confirming it. And Oppenheimer wasn't just watching from the sidelines. He was right there in the thick of it, one of the first American physicists to truly understand and apply quantum mechanics. He studied under Max Born in Germany, one of the founders of quantum theory. He came back to the United States and helped build American theoretical physics from almost nothing into a world power. And he saw what quantum mechanics really meant. It meant that the building blocks of reality are fundamentally uncertain. It meant that matter doesn't really exist in the way we think it does. It meant that underneath the apparent solidity of the world, there's this seething chaos of probability, where particles flicker in and out of existence, where energy and matter transform into each other constantly, where the rules we learned in everyday life simply don't apply. Something doesn't add up when you try to picture atoms as little solid things. And Oppenheimer figured out that they're not solid things at all. They're more like localized disturbances in underlying energy fields. Points where the fields get concentrated. Knots in the fabric of space. And inside those knots, inside the nucleus itself, he found something even stranger. The forces holding the nucleus together are so powerful, they make electromagnetic force look like nothing. The strong nuclear force, the thing that glues protons and neutrons together, operates at a scale and intensity that we have no intuition for. It's so strong that when you break it, when you split an atom, you release energy that can level cities. And Oppenheimer understood this better than almost anyone alive. Picture this. Imagine you could shrink down, past the size of a human, past the size of a cell, past the size of a molecule, smaller than bacteria, smaller than viruses, down below the wavelength of visible light itself, into a realm so tiny that the distance across an atom would seem like miles. What would you see? Not little balls, not solid matter. You'd see fields, rippling, vibrating, overlapping energy fields extending in all directions. You'd see disturbances in those fields, waves of probability washing through space. You'd see apparent particles winking into existence and vanishing again in time spans so short they make a billionth of a second seem like an eternity. This is the quantum vacuum, and it's not empty at all. It's seething with virtual particles, pairs of matter and antimatter appearing spontaneously from nothing, existing for an unimaginably brief moment, and then annihilating each other back into pure energy. This is happening everywhere, all the time. In the space between atoms, in the space inside atoms, even in the deepest void of outer space. The vacuum isn't nothing. It's everything, flickering in and out of existence faster than any clock could measure. Oppenheimer didn't just understand this theoretically, he did important work on it. In 1930, he and his student Harvey Hall published a paper on the relativistic theory of the electron, contributing to our understanding of how electrons behave at high energies. He worked on the theory of pair production, the process where pure energy transforms into matter and antimatter particles simultaneously. This is real alchemy, the kind medieval chemists dreamed of. Not turning lead into gold, but turning light into matter. Einstein's E equals mc squared made manifest. Energy and mass are the same thing, just in different forms. And the conversion factor, the speed of light squared, is so huge that even a tiny amount of mass contains an almost incomprehensible amount of energy. Let me walk you through this so you really feel it. Take a single gram of matter. Any matter. A paperclip. A raindrop. A piece of lint. If you could convert that single gram entirely into energy, you'd get about 21.5 kilotons of TNT equivalent. That's roughly the same as the bomb dropped on Nagasaki. 1 gram, the weight of a dollar bill. That's how much energy is locked inside ordinary matter. Every atom is a tiny imprisoned sun. The energy holding the nucleus together, if released, could power your house for days or destroy your entire neighborhood in a flash. And this is true of every atom. The coffee cup on your desk, the air in your lungs, your own beating heart, all of it is frozen energy. All of it is violence in temporary equilibrium. Oppenheimer saw this. He saw it mathematically, precisely, with the cold clarity of equations. And then he was asked to unleash it. Here's a way to think about the forces inside the nucleus. You know magnets, right? You put two magnets together with the same poles facing, and they push apart. You can feel that force in your hands. Now imagine a force about 100 times stronger than that electromagnetic repulsion. That's the strong nuclear force. It's the strongest force in the known universe, but it only works at incredibly short ranges. About 1 femtometer, which is 1 quadrillionth of a meter. Beyond that distance, it drops to basically nothing. Within that distance, it's overwhelming. It binds quarks into protons and neutrons. It binds protons and neutrons into nuclei. It's why matter can exist as anything more complex than hydrogen. Without the strong force, nuclei would fly apart. Protons are all positively charged, and positive charges repel each other. In a nucleus, you've got multiple protons crammed into a space smaller than a trillionth of a centimeter. The electromagnetic repulsion trying to blow them apart is immense. But the strong force, at those tiny distances, is even stronger. It wins. The nucleus holds together. But here's the crucial thing. It's a close contest. The protons are always trying to fly apart. The strong force is always barely winning. It's like a constant arm wrestle happening in the heart of every atom. And if you can shift that balance, even slightly, if you can get a nucleus into a configuration where the repulsion wins for even an instant, you get nuclear fission. The nucleus splits, and when it splits, it releases energy, a lot of energy. Because the masses of the fragments add up to slightly less than the mass of the original nucleus, and that missing mass has gone somewhere. It went into energy, into motion, into heat, into the kind of energy that, in 1945, vaporized 2 cities. Close your eyes for a second and visualize this. You're standing in the desert outside Alamogordo, New Mexico. It's July 16, 1945, 5:15 in the morning. Still dark, You're 10 miles from ground zero, which seemed like a safe distance when they set up the observation points. Oppenheimer is nearby. He's been awake for days. He's lost weight, chain smoking, running on adrenaline, and the pure nervous energy of having spent nearly 3 years building something nobody knew for certain would work. The gadget, they call it. A plutonium implosion bomb. A sphere of precisely shaped explosive lenses surrounding a core of plutonium-239 about the size of a softball. In a few minutes, they're going to detonate it. Some scientists have placed bets on the yield. A few have calculated whether it might ignite the atmosphere, setting off a chain reaction that would burn away all the nitrogen and oxygen in the air and sterilize the planet. They did the math. They said the chances were near zero, but near zero isn't zero. Now, imagine the countdown, the final seconds. And then, light. A light brighter than anything anyone had ever seen. Brighter than the sun. Oppenheimer later said it brought to mind a line from the Bhagavad Gita. Now I am become death, the destroyer of worlds. In that moment, the forces inside the atom, the forces that Oppenheimer understood better than almost anyone alive, were unleashed in a way that changed human history forever. The temperature at the center of that explosion reached about 100 million degrees. For comparison, the surface of the Sun is about 10,000 degrees. This was 10,000 times hotter than the Sun. At that temperature, matter doesn't exist the way we normally understand it. Atoms are ripped apart. Nuclei are stripped of their electrons. Everything becomes plasma, a fourth state of matter where particles move so fast the normal rules of chemistry stop applying. In a fraction of a second, the bomb converted about 1 gram of matter, 1 gram out of over 6 kilograms of plutonium, into pure energy. Just 1 gram. Less than 1% of the fuel actually fissioned. And that was enough to create a fireball that expanded to several hundred meters wide in milliseconds to generate a shock wave that could be felt over 100 miles away, to melt sand into glass, to announce to the world that humanity had found a new way to kill itself. And here's where Oppenheimer's real discovery becomes clear. He didn't just learn how to split atoms. Lots of people contributed to that. What Oppenheimer truly discovered, what he saw more clearly than almost anyone, was the nature of the atom itself. He understood that matter is not what we think it is, that solidity is an illusion, that what we call physical objects are actually condensed energy held together by forces operating at scales too small to imagine. And he understood what it meant to disrupt those forces. He saw that the atom, that building block of everything, is both creation and destruction wrapped up in one. The same force that binds protons together, if overcome, releases energy that can power civilization or end it. The strong force gives us the periodic table, chemistry, biology, life itself. And the strong force, disrupted, gives us nuclear weapons. This duality haunted Oppenheimer. It's why he could never be simply proud of his accomplishment. He hadn't invented something new. He'd uncovered something that was always there. The capacity for destruction was built into the architecture of matter from the beginning. It was written into the equations, and once you see it, you can't unsee it. And this is where Oppenheimer realized something that most people never think about. You're not ready for this next part, but I'm going to tell you anyway. Drop a comment right now and tell me where you're watching from. I'm always curious where in the world people are who want to understand this stuff, and I want to know how far this reaches before I get to the most disturbing part of all. The discovery Oppenheimer made wasn't just about atoms. It was about you. It was about what you actually are at the most fundamental level. See, everything I've told you so far about atoms, the emptiness, the probability clouds, the forces, the trapped energy. That's all true of the atoms inside your body, too. You're made of about 7 billion atoms. Each one is mostly empty space. Each one contains nuclear forces strong enough to destroy buildings if released. Each one is not really a solid thing, but a disturbance in quantum fields. Which means you're not really a solid thing either. You feel solid to yourself. You have a sense of being a continuous, persistent physical object moving through space and time. But zoom in far enough, and there's no solid thing there. There's no clear boundary where you end and the rest of the universe begins. At the atomic level, you're a process, not an object. You're a pattern of energy that happens to be maintaining itself through time. Atoms flow through you constantly. The atoms in your body today are not the same atoms that were in your body 7 years ago. You've shed them and taken in new ones. You're more like a wave than a particle, more like a flame than a log. The flame has a shape, an identity, a continuity, but it's not made of any fixed substance. Matter flows through it while the pattern persists. That's what you are, a pattern. And Oppenheimer understood that this pattern, this temporary arrangement of atoms that calls itself you, is held together by forces that could, in principle, be disrupted. Not just in a nuclear bomb. In ordinary processes. Radioactive decay is happening inside your body right now, at this very moment. You contain radioactive isotopes like carbon-14 and potassium-40 that are constantly undergoing nuclear decay. Particles are being ejected from atomic nuclei inside you at speeds close to the speed of light. You are, in a very real sense, slightly radioactive. And that's totally normal. It's just part of what matter does. The forces inside atoms are dynamic, probabilistic, uncertain. There's no perfect stability. Everything is in motion, in flux, in a kind of cosmic shimmer that we experience as solidity only because our senses are too slow to see the vibration. Oppenheimer said the physicists have known sin, and this is a knowledge which they cannot lose. What did he mean by sin? He wasn't a conventionally religious person. He drew from many traditions, Hindu scripture, Western philosophy, the hard pragmatism of physics. I think he meant that understanding how matter really works gives you a kind of terrible power. Not power over other people, necessarily. Power over reality itself. The power to see through the illusion of solidity. To recognize that the seemingly stable world is actually fragile, held together by forces that can be disrupted. To know that cities can vanish in milliseconds, that 100,000 people can die in less time than it takes to blink, not through malice or effort, but through the simple release of energy that was there all along, waiting. That knowledge changes you. You can't pretend the world is safe anymore. You can't look at matter the same way. Every object becomes a store of frozen violence. Every atom becomes a reminder that existence is conditional, that the forces keeping things together could, under the right circumstances, be overwhelmed by the forces trying to tear them apart. And here's what really got to Oppenheimer. This knowledge, once discovered, couldn't be undiscovered. You can't put the genie back in the bottle. He knew that even if America had never built the bomb, someone else would have. The physics was there. The mathematics was inescapable. Nuclear weapons were latent in the structure of matter itself. Humanity didn't invent nuclear energy. Humanity discovered it. It was always there. Inside every star. Inside every atom. Inside you. We just finally figured out how to access it. And now we can never go back to not knowing. The implications for your own existence are staggering once you really sit with this. You're not made of solid stuff. You're made of energy temporarily organized into a pattern called you. Every atom in your body is a tiny trapped sun, an absurd amount of energy held in balance by forces we barely understand. And the fact that you exist at all is kind of miraculous. Think about the statistics. Your body requires roughly 7 billion atoms to be arranged in exactly the right way. Each of those atoms had to be made somewhere. In the cores of stars, in supernova explosions, in the chaos of the Big Bang itself. The carbon in your cells was forged in the nuclear furnace of a star that died before our solar system even formed. The iron in your blood was made in the cataclysmic collapse of massive stars, scattered across space in explosions so bright they briefly outshone entire galaxies. You're literally made of stardust. That's not poetry. That's physics. The atoms in your left hand might have come from a different star than the atoms in your right hand. You're an assembly of cosmic debris, gathered over billions of years, temporarily holding a shape, capable of contemplating its own existence. Oppenheimer understood this, and he understood what it meant that this delicate pattern, this improbable arrangement of ancient atoms, could be dispersed back into chaos in an instant. At Hiroshima, roughly 80,000 people died immediately. By the end of 1945, the death toll was about 140,000. Most of them weren't soldiers. They were ordinary people, shopkeepers, children, grandmothers, who were turned from living patterns of organized atoms into heat and scattered matter in the time it takes light to cross a room. The energy released was equivalent to about 15,000 tons of TNT. The fireball reached temperatures that vaporized flesh, bone, concrete, steel. People close to the hypocenter simply ceased to exist as distinct entities. Their atoms didn't disappear. They just stopped being organized into anything recognizable as human. And Oppenheimer lived with this knowledge. He didn't just know it abstractly. He had made it happen. He had directed the project that turned atomic physics into atomic destruction. And afterward, he never recovered. Not really. In 1954, the Atomic Energy Commission stripped him of his security clearance in a humiliating hearing that basically accused him of being a security risk. His communist associations from the 1930s, which had seemed incidental at the time, were used against him. But really, the hearing was about his opposition to the hydrogen bomb, about his belief that there were limits to the kinds of weapons humanity should build. He had seen what nuclear weapons did. He didn't want to see worse. The hearing broke him publicly. He continued teaching, continued thinking, but something had gone out of him. He died in 1967 at 62 years old, having spent the last decades of his life trying to promote the peaceful use of atomic energy, trying to put some good back into the world after what he had helped unleash. His was a tragic arc. The brilliant young physicist who saw deeper into matter than almost anyone, who was given the power to transform that knowledge into reality, and who spent the rest of his life grappling with what he had done. But here's the thing. The physics doesn't care about tragedy. The physics just is. The strong force binds nuclei. Mass converts to energy according to Einstein's equation. These are facts about reality, as impersonal as gravity. What Oppenheimer discovered wasn't good or evil. It was just true. And the truth is that you're made of the same stuff that powers nuclear weapons. The energy inside your body, if fully converted, would release more destructive power than all the bombs ever detonated in human history. You're sitting there right now, watching this, and inside you is enough energy to level a city. You don't feel it. You can't access it. The forces holding your atoms together are so strong that under normal conditions, that energy stays locked away forever. but it's there. It's always been there. In every rock, every tree, every cloud, every drop of water in the ocean. We live in a universe where destruction is built into the building blocks of creation, where the same force that makes matter possible also makes annihilation possible, where nothing is solid, nothing is permanent, nothing is as stable as it seems. And once you see that, really see it, you can't look at the world the same way. So next time you touch something, anything, a table, a wall, another person, remember what's actually happening. You're not touching anything. You've never touched anything in your entire life. What you feel is electromagnetic force, electron clouds repelling each other across empty space. Your entire experience of physical contact is a sensory interpretation of force fields interacting. And inside those atoms that seem so solid, inside that matter that feels so real, there's almost nothing there. Just emptiness and force and unimaginable energy waiting. That's the world Oppenheimer saw. A world where matter is a kind of controlled explosion in slow motion. Where everything we think is stable is actually dynamic, temporary, hanging in balance by forces so powerful we can barely comprehend them. The atom isn't a tiny building block. It's a miracle of engineering at a scale we can't really visualize. It's creation and destruction held together, inseparable, two sides of the same reality. And Oppenheimer looked at that. He did the math. He followed the equations wherever they led. And then he had to decide what to do with the knowledge. He chose to build the bomb. Whether that choice was right or wrong, history still debates. But the physics would have been discovered anyway. If not him, someone else. If not in 1945, then in 1950 or 1955. The knowledge was coming. It was always coming. It was always there, hidden in every atom, waiting for someone clever enough to find it. Now you know what Oppenheimer knew. You know that solidity is an illusion. You know that matter is mostly empty space held together by force. You know that inside every atom is energy beyond comprehension, energy that creates stars and destroys cities. You know that you yourself are a temporary pattern of this strange stuff, an arrangement of ancient atoms briefly taking the shape of a person before dispersing back into the cosmos. Can you look at the world the same way after knowing this? Can you look at your own hands, your own body, the room around you, and see it as solid anymore? Or do you now see it as Oppenheimer saw it? A shimmering dance of probability and force, beautiful and terrible, creative and destructive, balanced on a knife's edge between being and oblivion? The secrets in the atom haven't changed. They were there before we knew them. They'll be there long after we're gone. What changed is us, our awareness, our power, our responsibility. Oppenheimer couldn't undo what he learned. And now, neither can you. If this video changed how you see reality, smash that like button so I know this stuff matters. And if you want to keep going down this rabbit hole with me, hit subscribe and the bell. Because every week I'm exploring more of the secrets physics doesn't usually tell you. Drop a comment telling me which Oppenheimer discovery you want me to explore next, because there's so much more to this story. Thanks for watching.